Assalamualaikum everyone, welcome to my brand new video. Today I am gonna tell you about how you will construct the time series model. Basically I will try to explain you step by step from unit root to co-integration to construct a regression model. So I will try to explain you in details. Most of us know about how to run the unit root test or how to run co-integration test separately, but we don't know about the steps like if the data set are non-stationary, what we need to do, which types of test is best fit for which kinds of model. So I'll try to explain in details. So I hope this video will be very helpful for you. So let's get started. So here you can see that my data set are from 2001 to 2020 and there are basically three variables: GDP, import and export. So first of all we need to declare the data set as time series data. So this is our first step to run the model in STATA. So to declare the data set as time series, we need to go to statistics, then you need to go to time series, setup and utilities, declare data set to be time series data. Then you have to select here time variable. Here my time variable is year, and here you need to select if your data are yearly data or yearly data or daily data. You need to select that. As my data set are yearly data and I will select that, then I will click OK. So the data set has been declared as time series data. So the first step is done. After that we need to conduct unit root test. So we basically run unit root test to find out if the data set are stationary at level or stationary at first difference. So for conducting any kinds of study, the data set need to be stationary. So to find out at which level the data set are stationary, we conduct unit root test. There are different kinds of unit root test like augmented decay-Fuller test, Philip-Perron test, DF-GLS test. The first two is the most popular time series unit root test. For conducting a study, you have to run at least 2 unit root tests. You can run more than 2 unit root tests. Basically, I will conduct the augmented decay-Fuller test, then I will cross-check the result with the Philip-Perron test. You need to cross-check the result. So you have to conduct the unit root test of all of your variables. Like there are 3 variables of my study, so I need to conduct the unit root test of all the 3 variables separately, and I need to find out at which level the variables data set are stationary. So we need to go to statistics, then we need to go to time series, then tests, then augmented decay-Fuller unit root test. You have to click on this. Then here you have to select your variable. Here I will first conduct the unit root of GDP. So here also the 3 options you can select. That first one is suppress constant term, include trend term or include drift term. You can cross check with selecting on by on, and here you have to select the lag difference on always. So first of all I will select the suppress constant term. So I will click on submit. So here the result of augmented decay-Fuller test. Here the null hypothesis is that there is unit root, and the alternative hypothesis is the data set are stationary. So this is the t statistics value. If the t statistics value is less than 5% or 1% critical value, then we cannot reject the null hypothesis. In most of the study we basically consider the 5% critical value, so I will consider here also the 5% critical value. As here the t statistics value is less than 5% critical value, irrespective of any sign, means we can ignore the plus sign or minus sign. We need to find that if the absolute value of t statistics is less than absolute value of 5% critical value or not. As here the t statistics absolute value is less than 5% critical value, we cannot reject the null hypothesis, and the null hypothesis is there is unit root. That means in this case the GDP data is not stationary at level. So now we need to run another option to cross check if we include the trend, if it is stationary at level or not. So after that we will click submit. Here again you can see that t statistic value is less than 5% critical value. That means if we include the time trend, then at that time also the GDP data is not stationary at level. As the GDP variable is not stationary at level, the next step is you have to generate fast difference variable of GDP. So to create the fast difference variable of GDP, you have to write the command generate space your new variable name equal to d dot your original variable name. Here I will write here GENERATE space give a new variable name dGDP equal to I have to write d dot my previous variable name, that is GDP. So here you can see that my fast difference variable of GDP has been created. Here you can see my fast difference variable of GDP. Now we need to conduct again the test to find out if the fast difference of GDP is stationary or not. So for this we need to again go there and then to select here variable dGDP, and we will select first the suppressed constant term, then we will select the trend term. So if we select the suppressed constant term for fast difference of GDP and click on submit, we can see that the t statistics value is greater than 5% critical value irrespective of any sign. So here we can reject the null hypothesis and accept the alternative hypothesis, and the alternative hypothesis is the data set is stationary. That means the GDP data is not stationary at level, but the GDP data of fast difference is stationary. That means the GDP is stationary at fast difference. Now you can cross check the result by selecting include time trend. So what we have found that the GDP data is not stationary at level, but it is stationary at fast difference according to augmented decay Fuller test. Now we will conduct the Philip-Perron test to find out if our result is consistent with the Philip. Now we will conduct the Philip-Perron test to cross-check the result of augmented decay Fuller test. So for this we need to go to statistics, then we need to go to time series, then tests, then Philip-Perron unit root test. So here I have to select the variable GDP. Then I have to select here again the number of lag on. Then there is also two options, suppress constant term and include time trend. First I will conduct with suppress constant term and I will click on submit. So here you can again see that the t statistics value is less than the 5% critical value. That means according to Philip-Perron test also the GDP data is not stationary at level. So if now we conduct with include time trend, we can see that the result is also consistent, that if we include the time trend also the GDP data is not stationary at level. That means the t statistics value is less than 5% value. So after that we need to again conduct with the fast difference with the Philip-Perron unit root test, and we will select here the suppress constant term first. Then we will click submit. Here we can see that the absolute t statistics value is greater than the 5% critical value. That means we can reject the null hypothesis and we can accept the alternative hypothesis. The alternative hypothesis is the data set are stationary. So according to Philip Barron test also, the data set are stationary at first difference. And now if we select the include time trend and submit, we can again see that the t statistics value is greater than 5% critical value. So the parent unit 2 test result is consistent with the augmented Dickey-Fuller test. So we have found the conclusion that GDP is not stationary at level, but it is stationary at fast difference. Then according to this procedure, we need to run the unit root test of import data and export data, and we need to find out at which level they are stationary. So after conducting this unit root test, the next step is we need to find out the optimum lag. So optimum lag selection is necessary in this case, because in the case of time series we assume that present year data are some extent is influenced by the previous year data. So before conducting the co-integration test, we need to run optimum lag selection. So for this the command is varchok space dependent variable then independent variable. If you first give the independent variable then dependent variable, then it will influence the result. So for this you have to write here first the dependent variable then the independent variable. As you will run the regression later, the regression's dependent variable, here you have to give that. If we go to the STATA, then we have to write here varchok space my dependent variable is GDP and my independent variables are import and export, and we have to press enter. Here you can see that according to the selection order criteria, here according to LR criteria, AIC, HQIC, according to all selection criteria, the optimum lag has been selected, lag 4. So now if in your study if the result is like that some of the criteria has selected lag on and some criteria has selected lag 4, so you have to select the smaller on lag on at that time. In my study all the criteria has said that lag 4 is optimum, but if in your study the star side has been given on according to LR in lag on and according to AIC and lag on and others on lag 4, you have to select the smaller lag, that means lag on, because the smaller the lag value the greater will be the accuracy of result. So I have found my optimum lag for the model. So next step is to run co-integration test. So basically we conduct the co-integration test to find out if there is long run relationship among variables or not. As the video would be more lengthy if I discuss all other processes like co-integration, multicollinearity, regression, so I will explain those things in my following videos. So keep with my channel. In my next video I will explain rest of the processes.